The last, actually very short tutorial is just to give you an idea of how to do toy studies. Now, toy studies we use if we want to understand how well our fit converges, what's the reliability, which means we sample from the PDF distribution and fit to that, sometimes varying certain parameters, and basically we assess the stability of the fit. So here we just use a simple Gaussian. We can now use, as we've seen before, any kind of model. The interface is exactly the same, whether it's 10,000 lines of code to create a model or just one single line, it doesn't matter. Sorry, yeah. Now I did exactly this. I executed the same cell block again. What we do here, as opposed to using sample as before, we use create sampler. And create sampler is more efficient than the other thing. It has a resample thing. So we define here how many points, and we say fixed parameters true, but this is actually by default true. I just put it here to make you aware that if we now sample from this, usually the parameters have a global state, meaning if we change their value, then everything changes. If we evaluate the loss again, then this always depends on these global parameters. If we say though, fixed params here for the create sampler, and create sampler basically remembers the values of these parameters. That just does it by default. So if you resample, it samples again as the parameters were in this state. Meaning if you don't put anything, it's the expected behavior, basically. What we do here is we build the loss, and we can also use this default toy strategy, which just in case it can't minimize and it fails with NANs, it doesn't raise an error as the other one does normally, but it just returns a fit result that says it's not valid. If you do toy studies, we may just want to do that and throw it away because we're doing statistical studies. Now, doing toy studies means we just sample and fit a couple of times. We can collect the fit results here. We get all the free parameters to reset them again. And the first thing we can do here inside is now we take, so to note that the ambient log likelihood that we built is with the model and now with the sampler. So the object that we got down here. Now, the first thing to do is to resample. So we now actually create a sample. Before we don't have a sample yet in there, but here we create the actual sample. And this is like regenerating. And then we can randomize our initial parameters. We can use the randomize, which use the whole range, or we can assign it manually just using some dictionary and setting the values. That's up to the experimentalist, let's say. Sometimes if we have many parameters and we get NANs, we may also just want to try if the loss is actually an NAN or not, and just try to find initial values where it's not NAN. But this is the whole, let's say, physical problem, not really a statistical one to find values and how to do that. And then we do the same over again. We see here that the loss doesn't change anyhow just because we're using a sampler, no difference. We minimize it, we create a minimizer here before, right? We minimize it exactly the same, whether it's sampled or not. And we say basically if the result is converged, then we call hepstat on it and we append it to our list here and we say, yeah, just a bar update, which means if you run this kind of things, we get now like 20 toys. If you've seen the bar below, I can also make it a little bit larger to show you again how it's going. Yeah. So you get an estimate of how the toys work and how things roughly are. And with that, we get then our fit results stored. So these are now 200 toys. We get our fit results in this list. And with this, we can now evaluate our results, meaning we can access everything in there, right? There's the params, we can get their values out, we can compare them, we can plot them, we can do whatever we want. But this then is doing analysis on this and not per se the fitting itself. This was everything from my side on the tutorials and everything. I hope you enjoyed it, learned something, and maybe also have any questions.
Thank you very much, Jonas, for the tutorial. I have actually a question about statistical interpretation. So you have built-in tools for toy studies, but do you have anything for resampling of the data? Like if I want to do some bootstrap studies, do you have some tools also for this?
So there is no direct. So Sean, there's no, surely not built in. I think what you can do is to just bootstrap and resample with pandas, for example.
Well, yes, yeah, of course.
Yeah.
I mean,
yeah,
this is clear. I wonder if since you already have this data object,
yeah.
right?
The thing is, I think a colleague of mine has actually done that, and this worked out quite nicely. Actually, she has even done a bind fit with zfit, which I promised before is not possible. But if you can also, we've seen now this unbind negative log likelihood and stuff. What you can also have as a side note is a custom loss, and the custom loss accepts any kind of function. So if you want to do a bind fit with zfit, although it's not officially supported, you can do it with 10 lines of code. She has actually done a bind with that, and also done this bootstrapping, I think, with pandas. It may, I mean, if you, I mean, feel free to make an issue there. We already had this request a little bit, and I think the more general idea is to have this kind of sampler object that you can assign a new value, which may be safer to do more general. Because the point is just that it's surely nice to bootstrap, but on one hand, there are other libraries that can do that already well, so you can't just wrap them. And on the other hand, it's just every feature that you add in the end adds up. So the main goal is to provide a very simple way to do it. There is even, I think, a bootstrap library now in scikit-hep, or even, yeah, there was a talk, I think, on scikit-hep about that. So the idea is then that you maybe have your data object and you can really just with 1 or 2 lines of code bootstrap with another library and put it back into zfit. So that, I think, would be the design goal of these things.
Okay. Well,
for the data object, you can even say to pandas.
Well, yeah, okay.
And from pandas, so which means it's like you would maybe just write 1 line of code, and now you need to write, let's say, 3 lines of code. But on the other hand, you have the full flexibility. You can do everything you want.
Yeah. I see. Okay. Thank you for the answer.